Okay, everybody. This is it. Final video of the day. We are going to be solving equations using logs to solve equations that have exponents in them. And that's a pretty typical use of logarithms. In fact, it's one of the main reasons that we study logarithms. And there's a comment I have to make at the beginning, which is when you look at one of these problems, like part A, there's a base 3 to the power x plus 5. You might think that we would use a logarithm in base 3, but in fact, we don't have to. We can use any base we want. So the general idea that we're going to use is that if you have an equation, something equals something else, then you can put the left side inside of a log and the right side inside of a log, and they'll still be equal. And you can do this with any log that you like, and in particular, we will typically use either just the log in base 10, which is log, or we will use the natural log, which is the log in base e. I'll go back and forth between these two. It doesn't matter which one you use as long as you use the same one in the same problem in the throughout the work that you're doing there. Okay, so let's look at the basic idea here. Part A, 3 to the power x plus 5 is equal to 8. Now, this is similar to problems that we ran into in the previous example, except, and so you might be tempted to try to rewrite this 8 as a power. We can do that. It becomes 2 to the power 3. But the problem is that we have a 3 to a power, and then this will be a 2 to a power. They don't have the same base, and it means we cannot drop the bases there. So instead, I'm going to take a different tack. I'm going to take the log of both sides. Now, you can use any logarithm base that you want. I would recommend using either the log, which is base 10, or the natural log, which is base e. And it really doesn't matter which one you use. I'm going to use the natural log. Take natural log of both sides. And I'm going to say you could use just the log in base 10 instead if you want. It's just all personal preference. You will get the same answer in the end. Okay, what does this mean? It means that we take a natural log and put the entire left side in it. And that's going to be equal to natural log and put the right side in it. Okay. How does this help us? Well, the whole reason is to use the rule of logs, which says that when you have a power, you can move that power down into front, and it will be connected to the log by multiplication. So when we move that x plus 5 down, we get x plus 5 times the natural log of, and the only thing left there is a 3. Now, natural log of 3 is not a number that I know offhand. Your calculator can give it to you. I'm just going to leave it for now as natural log of 3 because it's an exact number, and replacing it with a decimal, we're going to lose some of the exactness. We'll have to approximate it. So the right-hand side is still just natural log of 8. Now, we're trying to solve for x, and there's one x in this equation here. It's in here, x plus 5. Remember that this ln of 3 is just a number. You can get that number from your calculator, but this is like a number being multiplied by parentheses. And so we're going to take this entire natural log of 3 and distribute it to each of the things inside. So what do we have? We have x times the natural log of 3 plus 5 times the natural log of 3 is equal to the natural log of 8. We want to get that x by itself, and to do that, I'm going to subtract off that 5 ln 3 on both sides, minus 5 ln 3. So on the left, we have x times ln 3 is equal to ln 8 minus 5 ln 3. And then the last thing that we're going to do is divide both sides by ln 3, because that will cancel off the ln 3 in front of the x there. So divide by ln 3. And this is x is equal to, and in order to get the answer, well, first of all, the answer is ln 8 minus 5 ln 3 over ln 3. That's true. And we can get a decimal answer for this. X is really equal to a number. We can get that by plugging it into a calculator. So let's see. We can do a fraction, and let's go ln 8 minus 5 ln 3 over ln 3. And altogether, this is equal to negative 3.107. And we'll make it approximately negative 3.107. We make it approximately because we rounded that off. So this is what our x is, approximately equal to. If you want an exact value for f, this is the shortest way you can write down the exact value for f, I guess. Maybe you could simplify it a little bit. But this is what we're looking for. X equals negative 3.107. And that is the number that, if you put it in for x, will make this equation true. Okay. I'm going to pause here. Please go ahead, work through the next example yourself, see what you come up with, and then come on back and we'll take a look at it together. Okay. So part B. A 13 to the 2x minus 4 is equal to 6. We're going to do the same thing here. It's very similar to the previous problem. We're going to start by taking a logarithm of both sides. Here, I'm going to choose to use a different log. Instead of using the natural log, I will use the log log, the base 10 log. Whoops. Ooh, haha. Here we go. Take log of both sides. Okay. What do we get? Well, let's see. We're going to have the log of 13 to the 2x minus 4 is equal to the log of 6. As long as you use the same kind of log, the same base on both sides, you can use any log you want. So let's see. From this, we're going to use the same strategy next, which is to use the rule that says a power inside of a log can be moved into the front. In some sense, the hard thing about the original equation is the fact that that x is up in the power, up in the exponent, and it's this step that gets that exponent, that x, down out of the exponent and down in front where we can sort of deal with it, where we can get it by itself. Okay. Now, what we did before at this stage was we distributed this log in 13 to both sides through the parentheses. Another alternative is that we can, since the log is connected to the parentheses by multiplication, we can just cancel off the log by dividing both sides by it. So let's divide by log 13 on both sides. Oh, I see. I'm missing my 6 there. Okay. So the log 13s cancel. We get 2x minus 4 is equal to log 6 over log 13. Now, this tempting thing, which is that we have here on the right-hand side now two expressions with a log, and they have the same base, so it would be nice if we could combine these together. But unfortunately, there's no rule that has one log divided by another combining in any nice way. We have a rule for when logs are added or when they're subtracted, but not for when they are divided. All right, because of that, we're just going to leave that as it is, and we're going to get the x by itself. To do that, we're going to add 4 on both sides, so that we have 2x is equal to log 6 over log 13 plus 4. And then we need to divide both sides by 2. So on the left-hand side, those cancel. On the right-hand side, it's just important that we divide each thing by 2. So the log of 6 over log of 13, when we divide that by 2, it's like multiplying by a half. It ends up with that 2 going on the bottom. And then we're also going to need to divide 4 by 2. So what does this turn into? It's the log of 6 over 2 times log 13. Plus, and then 4 over 2 is just 2. Now, once again, we can check this in a calculator by plugging all of this in, and it gives us a decimal answer. I won't do it for you here, but I encourage you to plug it into a calculator. Make sure that you get a correct answer out of it, and the whole thing should come out to be approximately equal to 2.35. So this is our approximate answer. This is our exact answer. This is the x that makes this equation true. Okay. If you have questions, please send me an email or make a comment. Let's go on to the next example. So the next one, part C. For this one, the added complication here is just simply that we have something to a power on both sides of this equation. But unfortunately, the bases are not the same. So on the left-hand side, the base is 5. On the right-hand side, the base is 2. If they happen to be the same base, then we could just forget the bases and set the exponents equal using our rule. But since the bases are different, we cannot do that. And so what do? We take the log of both sides. I'm going to choose to take the natural log. You could use the regular log. It doesn't much matter. So the rule with dealing with these x's and the exponents is just take the log of both sides. That's ultimately what we want to do. So we have the natural log on the left of 5 to the x minus 7. And on the right, the natural log of 2 to the x. And what we're going to do now is use the rule that allows us to move this exponent into the front and do the same thing on the other side. On the right-hand side, we can use the rule that moves this exponent into the front as well. So on the left, we're going to have x minus 7 times the natural log of 5. On the right, we're going to have x times the natural log of 2. Okay. Now we have this interesting conundrum, which is there's now 2 x's in this problem. There's an x on the right-hand side. It has a number next to it. Natural log of 2 is just a number. You can get it from your calculator if you want. I'm going to leave it as natural log of 2 here. On the left-hand side, we have this number, natural log of 5, times, and in parentheses, x minus 7. So there's an x here as well. So this one, I really do need to distribute this through. What we're going to try to do is separate out the parts that have x's from the parts that don't. So this is x times ln of 5 minus 7 times ln of 5 is equal to x times ln of 2. And what you'll notice is that there's 3 terms here, 1, 2, 3. 2 of them have x's in them, 1 and 2, and 1 of them does not. And so what we're going to do is move the term that does not have an x over to this side and move this x back over to that side so that we have all the x's collected on one side. We're going to add 7 ln 5 plus 7 ln 5, and then those cancel. And we're going to minus x ln 2 minus x ln 2, and those cancel. So on the left we have x ln 5 minus x ln 2 is equal to 7 ln 5. Now, it's looking closer. What we have is x and x, and each one has x times, and this is a number. Ln of 5 is some number. You could get it from your calculator. And this x is times ln 2. That's also a number. It's a different number. And the way that we handle this is we just have, since these two have this thing in common, the x in common, we just factor an x out of the left-hand side. So that it becomes x times ln 5 minus ln 2. Each term on the left has an x in it. We factor the x out, and this is what remains. 7 times ln 5 on the right. Okay. And finally, to get the x by itself, we just have to divide by what's in parentheses. So we divide by ln5 minus ln2. We divide by ln5 minus ln2. These cancel, and we're left with x is equal to 7 ln5 over ln5 minus ln2. Now, we have the x by itself. And on the right-hand side, these are all just numbers, except that they're kind of complicated. We have to use a calculator to see what they're equal to. You can plug this into a calculator just as we did with the others. Be sure to get the correct parts on the top and on the bottom of the fraction. And what you'll see is that this whole thing is approximately equal to 12.30. So this is our approximate answer. If you want a decimal answer, if you want the exact answer, this is as good as it's going to get. So this is our answer for part C. All right, go ahead and work on part D. Come on back, and we'll talk about it. Okay. 5.1 to the x is equal to 2.7 to the 2x plus 6. Look, this is a lot like the previous problem. It's just that the bases now, instead of being nice whole numbers, are now this annoying decimals, 5.1 and 2.7. How do we deal with it? We deal with it the same way. We start by taking the log of both sides, and you could either use the log, log, which is just the log in base 10, or you could use the natural log, which is ln. So, up to you. I'll use the log in base 10 since I used natural log last time. So we take the log of both sides. Log of 5.1 to the x is equal to log of 2.7 to the 2x plus 6. Now, the fact that those are decimals doesn't matter. The point is that it's a base raised to a power, and when we have a log of a base raised to a power, we can move the power in front. And I'm going to do this on both sides. Here we have x times the log of 5.1, and then that's equal to 2x plus 6 times the log of 2.7. We need to collect our x's together, so because of that, I'm going to distribute on the right-hand side. I'm going to distribute this log through my parentheses. So this is 2x log of 2.7 plus 6 log of 2.7. And what's that equal to? It's equal to x times log 5.1. Now, let's go ahead and take this term, which has an x in it, and move it to the left so we can combine it with this term, which has an x in it. So we subtract 2x log 2.7 on both sides. On the right, it cancels, and on the left, we have x log 5.1 minus 2x log 2.7, and that's equal to 6 log 2.7. Now on the left, we once again have two terms, and they have something in common. They both have an x. So we're going to pull those x's out into the front. We're going to factor an x out of the left-hand side. So this becomes log of 5.1 minus 2 times log of 2.7. And that's equal to 6 log 2.7. And the last step is to get that x by itself. We divide by the stuff in parentheses. So we divide by log 5.1 minus 2 log 2.7. And we do it on the right-hand side also. Log 5.1 minus 2 log 2.7. On the left, these cancel. And in the end, we get that x is equal to 6 times log of 7 over log of 5.1 minus 2 log of 2.7. Now, this is the exact answer, and of course, we can plug it into a calculator and get an approximate answer. The approximate answer is negative 16.68. That's rounding that off to 2 decimals. And if you want an exact answer, it's just this one here. Okay, this is our final answer for part D. Go ahead and take a look at part E, and we'll come back and do it together. Whee! Okay, let's take a look at part E. 17 to the x minus 2 over 3 to the x plus 4. All right. Once again, our first step is going to be take the log of both sides. So what do we have? We have ln of 17 to the x minus 2 is equal to ln of 3 to the x plus 4. Now, we use the rule that says we can take those powers and move them into the front. So we have x minus 2 times ln of 17, and that's equal to x plus 4 times ln of 3. On both sides, I'm going to go ahead and distribute the ln. On the left-hand side, the ln of 17, I'm going to distribute through. I get x ln 17 minus 2 ln 17. And on the right, if I distribute through, I get x ln 3 plus 4 ln 3. Now, terms with x's in them, I'm going to collect on the left. Terms without x's, I'm going to collect on the right. So we subtract x ln 3 from both sides. Cancels off on the right. We add 2 ln 17 to both sides. Cancels off on the left. And now we have on the left-hand side x ln 17 minus x ln 3. And on the right-hand side, we have 4 ln 3 plus 21 ln 17. On the left-hand side, I factor out an x. So this is x times ln 17 minus ln 3. And that's still equal on the right to 4 ln 3 plus 21 ln 17. Now we divide both sides by the stuff in parentheses. Divide by that ln 17 minus ln 3. And cancels on the left, and on the right we get altogether 4 times ln 3 plus 21 times ln 17 divided by ln 17 minus ln 3. So that's the exact answer, and for approximate answer, if we plug that into the calculator, we are going to get 5.80. Take a look, try plugging it in and see what you get, and let me know if you have any questions. Ooh, interesting. I've just noticed, looking back, that in fact I screwed it up, and this is a great observation because this is the kind of thing that would be easy to screw up, I think, for anyone, but I did it, so take a look. Here's what it is. I think this is wrong, and the reason I think it's wrong is that we started way back here with 2 times ln of 17, and then I somehow, when I copied it down, I wrote it as 21 times ln of 17. You notice there's an extra 1, that L split into 2 pieces or something like that. This is supposed to just be a 2 here in front of the ln 17. So let me just fix that like that, and we'll make it just a 2 in the front. And I'm going to continue to try to fix these guys. Get rid of that. That's 2 times ln of 17, and this one is 2 times ln of 17. I believe that that fixes this thing correctly, and I believe that the decimal answer I gave you originally was the correct decimal answer. It's this exact answer was incorrect. So apologies, and that's just a good lesson in terms of being careful with your work. Okay. Let's see, we have one more of these to go. Let's go ahead and do it, and then we'll be done for the day. Part F. Okay. Oh, wait a minute. That's part E. What the heck? Let's try it again. All right, we're going to try it again. Here we go. There. Get rid of that guy. Okay, F. 7 to the 2x plus 3 is equal to 11 to the 3x minus 6. What do? Well, we take the log of both sides. So we have that the log of 7 to the 2x plus 3 is equal to the log of 11 to the 3x minus 6. Now we bring the exponents to the outside. 2x plus 3 times log 7 is equal to 3x minus 6 times the log of 11. All right, we distribute the logs through, so this is 2x log 7 plus 3 log 7 is equal to 3x log 11 minus 6 log 11. Now, I move the terms that have x's in them to the left, and I move the other terms to the right. So I'm going to subtract 3x log 11 from both sides. And I'm also going to subtract 3 log 7 from both sides. Okay. On the left, we have 2x log 7 minus 3x log 11. And that's equal on the right to minus 6 log 11 minus 3 log 7. Okay. On the left-hand side, we factor out an x. So the x comes in the front, and we have 2 log 7 minus 3 log 11. And on the right-hand side, we still just have that minus 6 log 11 minus 3 log 7. We divide both sides by the stuff in parentheses. So we divide both sides by that. So divide and divide. Here it cancels. And what is x equal to? Well, it's just equal to what you see there. I'll recopy it for neatness' sake. Negative 6 times log 11 minus 3 times log 7 over 2 log 7 minus 3 log 11. Now, altogether, if we plug this into a calculator, we get that this is approximately equal to 6.13. This is our approximate answer. This is our exact answer. And that concludes our exercise 14.4, I believe it is. Okay, thanks everybody. Go ahead and try the web work, and best of luck.